Hello, everyone. We are so excited to have you join us today for the Certified Kubernetes Application Developer Lab Challenge with our lead labs content developer, Logan Rockeye. Before starting Lab Challenge, there are a few things of information that I need to share. The first is the webinar is being recorded and will be shared via email when it's available. At the end of the webinar, we will hold a live Q&A with Logan, so feel free to submit your questions through the Q&A box. Speaking of the end of the webinar, there will be a brief end of webinar survey. We truly appreciate your feedback as it helps us improve our webinar. But without further ado, I'm going to hand it over to Logan.
Hello everyone, and thank you for joining me for another live lab session here at Cloud Academy. Today's lab session is going to be revolving around the Certified Kubernetes Application Developer exam. And in particular, we're going to be doing a lab challenge, which is focused on the objectives of the CKAD certification. As a refresher, Cloud Academy provides a CKAD learning path, which includes 21 hours of content, including 5 courses, 2 lab challenges, and 28 hands-on labs. A very hands-on lab focused learning path, and that's because the CKAD exam is a performance-based exam. The exam uses real Kubernetes clusters where you have to demonstrate your ability to work with the cluster and create the resources and configure resources as specified with the particular tasks for the exam. So I'm going to jump down to the challenge that we'll be working on today, which is the last challenge in the learning path. And it's our Certified Kubernetes Application Developer Challenge, CKAD Challenge. And this challenge highlights a few areas that are unique to the CKAD exam. And the learning path includes several practice exams to help you get ramped up for these challenges at the end. And the practice exams do include full solutions so that you can really understand and get to learn how to solve those problems and approach them from different ways. We do really encourage everyone to retake the practice exams multiple times just to work on their speed, because the exam itself is fairly time constrained. I know the first time that you may take it, you may not get through all the questions. Hopefully with today's live lab session, we can help with some of the strategies for avoiding that, so that you do get time to at least attempt all the challenge questions. And with that, I'm going to start the lab challenge, and it will take a couple minutes for the cluster to spin up. You may choose to follow along, or you may choose to sit back, relax, and watch as I go through the challenge, and we'll solve these tasks together. And I'll explain things as we go. While we're waiting, I will highlight a few things from the Linux Foundation Certified Kubernetes Application Developer exam page, which is right here. And from this exam page, you can see the different domains and competencies. And you can drill down into each particular one as well. I'm not going to go over too much particulars for the exam, but I do want to highlight a few things. In particular, there is some recent changes with the exam proctoring for Certified Kubernetes Application Developer, as well as Certified Kubernetes Administrator, the CKA exam. I want to touch on that a little bit today. If you scroll down a little bit further, there's the exam details and resources, and this is really helpful for providing all the links that are useful for reading through and just getting ready for the exam. There's a candidate handbook, there's an exam environment demo, which shows you what the actual exam environment looks like. Cloud Academy's Lab Challenge environment does mimic this quite closely, as you'll see. I do want to also dive deeper into the exam tips. From here, you can see the exam includes 15 to 20 performance-based questions. It's a 2-hour exam. Results should be provided within 24 hours. Also, there's a highlight here at the top that the exam is switching to PSI Bridge, and that'll provide a slightly different exam experience for you. it will be using the PSI Bridge secure browser. So you won't be using your own web browser as was the case in the past. So if you're a first-time exam taker, that might be fine. If you are someone who's taken the exams before and you're renewing your exam or doing another attempt at the exam, things are going to look a little bit different. One thing I want to call out, because it usually comes up in each webinar that we have about CKAD, is are you allowed to use multiple screens? And in the past, you were allowed to do that. You are no longer allowed to use multiple screens, however. Another change with the PSI Bridge change-up is that you're no longer allowed to use your own web browser. It'll be the PSI Bridge secure browser. So one of the strategies for exams, particularly for the Kubernetes exams, was to create bookmarks to specific pages within the Kubernetes documentation, and that could save you some time during the exam. Now, because you'll be using the PSI Bridge secure browser, you won't have control in advance of the exam to create bookmarks. So that strategy no longer is available to us. However, the search functionality on the documentation is quite easy to use and quite responsive, so we won't be losing too much time. I'll try to demonstrate that today. You are still, however, allowed access to the documentation and a few other resources. So I'm going to jump over to that in another browser tab here. So for CKAD and CKA, you are still allowed to access the official documentation, the Kubernetes blog, as well as different translations, and you can use the search functionality of the documentation. One catch is if the documentation search results navigate to a page other than these allowed domains, and there's also the helm.sh docs, if the link navigates away from that, you want to avoid clicking on that link, because that could result in your exam session being terminated and making you ineligible to pass the exam on that attempt. So just one thing to keep in mind, don't click before just hovering your mouse over to make sure that the link is going to one of those allowed domains. So to get ready for the challenge, I have one browser tab already open to the official documentation, so kubernetes.io/docs, and I'll close these other two tabs just to better simulate the actual exam. Back in the lab, we see that the environment has reached 100% setup complete, so our cluster is ready. Now the instructions here outlining your mission will get you started with how to connect to the cluster. I'll just breeze through this. And let's go ahead and do that. So I'll copy the SSH command, go to validation steps, enter CA as the default username and no password, and then enter that SSH command to connect to the cluster. And we're in. So if you haven't used the Cloud Academy Lab Challenge environment before, you do have this option for the command line based challenges to maximize your screen. I'll do that and also zoom in a bit to make it hopefully easier for you all to read. And we have our checks on the right. So these are the tasks that we need to complete, similar to how tasks are going to be outlined in the actual CKAD exam. And at the bottom, there's a button to run the checks. So right now, we haven't done anything in the cluster, so these checks will all fail, and they'll be identified with a red background and a red X. One thing I want to highlight is back in the instructions, there is this command to use context, challenge context. If you followed along with the labs in the learning path, you may not see this very frequently, but this is something that is used in the actual exam for every task. And this is because in the actual exam, there's multiple Kubernetes clusters. So to make sure that you're targeting the right cluster, you need to set the context. So that's why we have this example context command, just to get you familiar with how the exam is actually going to work. Okay, so we switched to the challenge context. Now we're ready to start tackling these challenges. So number one, CKAD check one, service account. Create a service account named inspector in the DWX7EQ namespace. Then create a deployment named CAL ins in the same namespace. Use the image busybox131.1 for the only pod container and pass the arguments sleep and 24h to the container. Set the number of replicas to 1, and lastly, make sure the deployments pods is using the inspector service account. So there's quite a few different requirements for this. So let's just knock them down one by one. So creating a service account. Recall that service accounts are how pods are given identities in Kubernetes. So we want to create a service account named inspector in a particular namespace. And the most straightforward way to do that is use the kubectl create command. So create, and if I push tab 2 times, it'll list the available resources. Service account is one of the resources that we can create. And I will highlight here that in the actual exam environment, like our lab challenge environment, you do have the option of just using the alias k for kubectl. So instead of kubectl, you can just put k create. And just like the exam environment, you'll have the completions already set up for you. Now, if something goes terrible during the exam and somehow the completions are disabled, you can always reference the commands for enabling the completions from the documentation cheat sheet. So if you search for cheat sheet, you'll see the first result is the kubectl cheat sheet, and right at the top we have the commands for enabling completions. So you can just drop these in, and even setting up the alias is here as well. So just in case, that's right there for you. Okay, but I'm going to proceed with creating the service account in this particular namespace. So using the create command with the -n for specifying a namespace and giving the particular name inspector. Oops, I forgot to put service account. So service account inspector, and there we go. We created the inspector service account. Next, we need to create a deployment. So it's a couple different ways that we can go about creating a deployment. Again, we can use the create command. You see that deployment is one of the options. We can also look at existing deployments within the cluster and use that as a template. So we can use the kget deployment command and specify the output as YAML to generate a YAML file, and then we can use our command line text editor. I like to use VI. VI will be set up as the default in the exam environment, and you can use VI to edit that. And lastly, you can also search the documentation for deployments, and there will always be examples related to that. So if you just search for deployments, there's several use cases we can copy from the examples you find here. The cheat sheet also provides examples for many common resources. So if we just do a search for deployments, you may luck out and find something right on the cheat sheet page. The approach we're going to take today is to use the create command to initialize a template, so a YAML file. In the context of Kubernetes, a YAML file that declares resources is also often referred to as a manifest file. So I will be using those names interchangeably, manifest file or YAML file. Okay, create deployment. And we want to specify an image. So I'll get that from the task description and directly paste that just to make sure that there's no typos. And we can give it a name, CAL ins. And I don't want to actually create this, so I'm going to use the dry run command. And you can say dry run client. We're doing a client-side dry run, not sending it to the server. And set the output as YAML, so -o YAML. And that'll generate a template for you to start working with. And we'll need to customize it a bit here. In particular, the arguments to the command. We need to set sleep in 24H. Replicas is automatically set to 1 by default, so we didn't need to specify that in the command, but I'll show you. You can easily include that. Replicas equals 1. In the actual exam, you might have a different number of replicas, so you can specify that at the command line. And now I'm going to redirect that to a file, and during the actual exam, I don't want to spend too much time thinking about what to call the files, so I'll just use the task number 1.yaml as the name of the file. So now we need to modify this. And here we need to set the arguments. That's the last thing. The arguments need to be sleep 24H, and the service account for the pod in the deployment needs to be set to inspector. So a couple ways we can do this. I'm going to go back to the cheat sheet, and if I search for args, you can see how to specify arguments. So this is one way, using the hyphen on separate lines. You can also specify another way, which I'll show you, that you may be more familiar with. But this does go under the container object. Okay. So if I find containers, I'll add the args field. And using VI, you can press / and then type CONT, press enter, and it'll jump down to containers. And we want to add args. And we'll set 1 string per line with a hyphen. So first one is sleep. Next one is 24H. You may have also seen args being specified using square brackets, sleep, in quotation marks, comma, 24H. That's an equivalent way to do it in YAML, but I'll keep it using 1 string per line. And lastly, we need the service account. So in this case, a quick search of service account from the documentation should reveal an example that we can directly pull from. So managing service accounts, scroll down. In this case, we didn't see an example with the actual service account for a pod. So I'll go back. And this second result was probably better for us. Configure service accounts for pods. And we'll search through this to see how service accounts get specified. So under the spec for the pod, you have service account name, and then we'll specify, instead of build robot, we'll say inspector for our service account. Okay, and this is in the pod spec, so it has to be at the same level of indentation as the containers. And I'll copy the name to avoid any typos, and that'll specify the service account for that pod in the deployment. Okay, so I'll save this file. In VI, you escape and then press :WQ, right quit. That saves the file. You can then apply that manifest file or the YAML file, kapply -f 1.yaml, and that'll send it to the Kubernetes API server and create that resource. So if we now run our checks, we should see that the first check will pass, and we can also verify using our kubectl. So So maybe it hasn't propagated yet. Let me check. kubectl get namespace dwx deployments. In this case, there was no deployment there, so what I'm thinking is I forgot to specify the namespace in the YAML file, and that is correct. So here we can add the namespace here. This is one way to do it. You can specify it as part of the YAML file, or if you didn't do that, you can specify as part of the apply command, you specify -n and then the namespace that you want. Okay, so you can do one or the other. And I'll run that. So that first deployment would have created in the default namespace. Since we're simulating an exam environment, I won't waste time to go and delete that. Now we do have a deployment in our desired namespace. Okay, so I'll run the checks, and we should see that the first check has passed. Fingers crossed. Okay, so congratulations, first one's passed. In the actual exam environment, you won't be able to run checks during the exam. You would just move on when you think that you've achieved the desired result. And using the kubectl get and kubectl describe commands, you can almost, most of the time, you can verify that you do have the right solution working just by running those get and describe commands. Okay, so let's move on to the second check. This one is titled Evictions. The mission-critical deployment in BK0C2D namespace has been getting evicted when the Kubernetes cluster is consuming a lot of memory. Modify the deployment so that it will not be evicted when the cluster is under memory pressure, unless there are higher priority pods running in the cluster. Guaranteed quality of service. It is known that the container for the deployments pod requires and will not use more than 200 milli-CPUs and 200 megabytes of memory. Okay, so this touches on quality of service, which isn't super common to be dealt with, but it can come up. It is one of the things that should be understood for the exam, and you can search the documentation here quickly. This is covered in the CKAD learning path, but if I do a quick search for quality of service, you can see the different levels of quality of service that can be assigned to pods, and that impacts scheduling and eviction decisions. So guaranteed, burstable, and best effort. As a refresher, to be a guaranteed quality of service, you have to make sure that the pod has a request and a limit for both memory and CPU. Okay, and not only that, the request and the limit have to be equal in value. That allows you to have guaranteed quality of service. Now, if I just look up the mission critical deployment, so K describe -n BK0 tab deployment mission critical, you can see the quality of service that gets reported here in the output. Okay, in this case it's not being shown because there is no quality of service. That would be best effort by default. So anything that's not best effort or burstable will be, or sorry, anything that's not guaranteed or burstable, so basically anything that's left will be classified as best effort. Once we do reach the requirements for guaranteed quality of service, that describe output will display the desired guaranteed quality of service level, and I'll show you that after we complete this task. Okay, but now that being said, we know what to do. We just have to set the requirement and limit for the pod request. And this is a good case where we can use the documentation to quickly get a sample of what that looks like. So here is inside of a pod spec. In the containers field, there's a resources object, and you can set the limits and requests for both CPU and memory. So I'll just directly copy that. In this case, I want to just use kubectl edit to directly edit the manifest for the resource without creating a separate file. So we're in bk02c2d, deployments, mission critical. And if I jump down to resources, you can see that there is a resource object, but it has nothing in it by default. So I'll delete this line and paste in what we got from the documentation. We'll have to fix the indentation. So in VI, I can do that by pressing the greater than symbol, and then 6 lines, so number 6, and then pushing up. So that'll indent it 1 level. Then I'll do greater than 6 and push down, so the following 6 lines. And that brings it to the right level of indentation. And we had a requirement for 200 milli-CPU, so 200 lowercase m. The example had 700, so I'll search for 7, change that to a 2, search for the next 7, change that to a 2 again, and recall for guaranteed quality of service, the limit has to equal the request. So we have that now for CPU and also for memory. So memory needed 200 megabytes, and the example that we got already has that configured. So I'll press escape and then right quit WQ to save the file. And the output tells us that the resource has been edited. We can run our check to see if we did that correctly. And at the same time, I can use the describe command to see if we're displaying quality of service yet. In this case, we're not, so I'm going to check the output. There's no hints of what we may have missed, so let's go back and re-edit that deployment. And I'll search for resource, so /resource, and then press enter, and you can press N to jump to the next match. So here we have 200 milli-CPU, 200 megabytes for memory. That does look okay. Let me see if maybe there was some delay. Okay, so it did take some time to deploy the new pods and have them result in the guaranteed quality of service. And now that I say that, it does remind me that quality of service is a property of the pod, and before I was describing the deployment, so I actually want to describe the pod. So pod, mission critical will be the starting, the prefix for the pod. So mission critical, and then I'll just choose any of them. So F tab, and here is where that quality of service class will be reported. So it's a property of the pod, not the deployment. That's why I was missing it in the first attempt. But we do have our guaranteed quality of service now. So that verifies it. Let's move on to the next check. And this one's about persisting data. So a legacy application runs via deployment in the ZUC0C0CO space. The deployment's pod uses a multi-container pod to convert the legacy application's raw metric output into a format that can be consumed by a metric aggregation system. Okay, so a multi-container pod design pattern being applied there. However, the data is currently lost every time the pod is deleted. Modify the deployment to use a persistent volume claim with 2 GB of storage and access mode of read-write once, so the data is persisted if the pod is deleted. So let's start out just by checking out this deployment, and I'll use the get command. So we're in the namespace beginning with Z. Get -n, the namespace, deployment, and the deployment is called legacy. So I want to see the YAML output to get a manifest, so -o YAML, and I'll redirect that to a file. We'll just call it 3-deployment.yaml, and let's check that out. So I'll search for containers to jump down to the containers that we have in our spec. Okay, so we do have one container here and one container here. Okay, so this first container is named app, second one is named adapter. So a clear shout out to the adapter multi-container design pattern. For more on multi-container design patterns, you can refer to the Application Developer course in the CKAD learning path. But in this case, it's applying the adapter pattern to adapt the logs being generated by the legacy application to meet the requirements of a more modern ingesting system for logs. Okay, we do have the containers are already set up to use a mount point for volumes. So they both have the metrics /metrics volume mount path, and they're using the same volume named metrics already. So that's good. We don't have to completely set up the volumes from scratch. But let's see what volume is actually being used here. So right at the bottom we have volumes, and it's using an empty dir volume. So empty dir volumes have a lifetime tied to the lifetime of the pod. So that explains why the data is deleted whenever the pod gets deleted. What we need to do is change that to a persistent volume claim, which can have a lifetime that extends beyond the lifetime of the pod. Okay, so in this case, let's search for a quick example of a manifest for a persistent volume claim. So if I search for persistent volume claim, I'll click on this first result, which is about persistent volumes. And this documentation page, if you've gone through the CKAD learning path, you've probably already bookmarked this. And although we can't use bookmarks in the actual exam anymore, bookmarking can still be useful for your study purposes, just to go back and reference the different documentation pages. This persistent volume page also explains how to use persistent volume claims. They are. So to summarize, the persistent volume is the actual piece of storage that's being used, and the persistent volume claim is a claim to that storage. So just like we saw with the previous task, we were claiming specific CPU and memory resources by our pod. The persistent volume claim allows us to claim specific storage resources. Okay, so let's click on the detailed walkthrough with working examples to try to get a manifest example that we can use to start with. And you could search for persistent volume claim. Here's a nice short and sweet PVC claim example. You can click the copy button, and let's start editing that as our starting point. I'll just push :Q so that we don't make any changes, and I'll do 3-PVC for our persistent volume claim manifest file. Okay, so it came in with the name of task pb claim. This time around, I won't forget to set the namespace. Again, you can set it inside the manifest file, or you can set it when you run the kubectl apply or kubectl create command. The namespace we want is ZUC0CO. Okay, and storage class name here is not specified in the task. So that means that we should be using the default storage class. So we can delete this storage class name. Storage class names allow you to select different storage classes. So you may have in your environment different ways of providing persistent volumes. For our lab challenge environment, we're using Amazon's Elastic Block Storage, and that is configured as the default. So we don't need to actually specify a storage class name because we have a default, and I'll show you that right now. I'll save that. If I do k describe storage classes, you can see that we have the GP2 storage class that's set up, and there should be a default property. Is default class is set to yes. So that means that if we don't specify a particular storage class name with our persistent volume claim, it's going to use this. And this is using Amazon Web Services Elastic Block Storage. Okay, so that's why we don't need to specify the storage class name. The task wants us to use read write once, and we lucked out that we do have read write once as the specified access mode, and we need 2 GB. So if I press /3, it'll jump down to the 3 and delete that. Oops. And enter 2. So 2 GB. That's what we want. And now we can go ahead and create that. I'll use kubectl apply -f. And we don't need to specify the namespace because it's part of the manifest file. So there we are. We can get the PVCs in the Z namespace. So there we do have our PVC. Now we just need to modify the deployment resource so that it's using that PVC instead of the empty dir volume. So if I use KEdit and then -n for namespace and deployments and the legacy deployment. Now I can jump down to volume. So I'll search for volume, press N, get down to the bottom. We no longer want to use empty dir. We want to use persistent volume claim. If I jump back to the documentation, there should be an example of how to use that in a pod. So here we are. Instead of empty dir, we have persistent volume claim, and then the claim name is the field under that. And we didn't change the name of the PVC, so we can directly use this in our task. Oops. Okay, so claim name is task PV claim. That's the same name that we used when we created our PVC. So I'll save this. And now the deployment has been edited. If I describe the volume, or sorry, describe the deployment, we should see that we're now using persistent volume claim. So you can kind of verify for yourself that way in the actual exam. But in the lab challenge, we can run our checks to validate that we solved the task. So fingers crossed. And there we have it. So we validated, well, the Cloud Academy platform has validated for us that we did correctly set up the persistent volume claim. Okay, now there's only one more task left for this challenge, and that is check for multi-container pattern. Write the name of the multi-container pod design pattern used in the pod in the previous task to the file /home/ubuntu/mcpod. Okay, so short and sweet finisher. In the actual exam, you may be asked to redirect things to files in particular directories, so this is one way that we can demonstrate that. The actual design pattern that was being used was suggested by the name of the container, which was adapter. So we still have it on the output here. So that is the adapter design pattern for multi-container pods. So we just need to echo adapter and redirect that to the specified file. Okay, so this greater than symbol will redirect whatever's output to standard output into this file. So if we want to verify, we can use cat and then the name of the file. Oops, I deleted the D. And there we have the contents of the file is now adapter. So let's run that check. And hopefully at this stage we have completed all the tasks, thus fulfilling the requirements for the challenge. So there we have it. Check number 4 passes. All of the previous checks are passed. At this stage we have completed our challenge. So some things to highlight at this point. Always keep in mind when you can strategically use the documentation. So you don't want to spend too much time searching documentation during the exam. Like I demonstrated earlier, you can search and you may not click the best link to start with, and you can end up burning quite a bit of exam time doing that. In the past, we would recommend using bookmarks, but that strategy can no longer be used with the new PSI bridge system. But still, probably worthwhile to be familiar with a lot of the documentation pages, and you may want to use bookmarks as part of your study preparation. Okay. Also remember the cheat sheet, which has quite a few examples of common operations. If you want to search within this cheat sheet, you can often find what you're looking for. Okay. And last thing that I'll mention is consider the different ways that you can actually accomplish tasks in Kubernetes, so using the kubectl command line. Like we saw earliest in our challenge, you could use the create command to directly create resources. Sometimes you can't accomplish everything that's required using the create command. One example of that was the deployment we had to create needed customized arguments to the container command, and we couldn't accomplish that using the create command's available command line options. So in that case, you can still use create as an option to create a manifest file that is a template to start working with, and then customize it from there. You can search the documentation for what you need to customize. You can also leverage the explain command. And we didn't see this in the actual solution to the task, but sometimes you can use kubectl explain, and this will specify all the different fields available for anything that you would put in a manifest. So kexplain pod will say everything that's available in a pod spec, everything at the top level for a pod, and then within the pod.spec, this is everything in the pod spec. Okay, so this will have containers as one of its fields. I'll try to show you that. So containers. Then if you want to see what options are available for a container, you can put pod.spec.containers. And then args would be one of these options here. Okay, and sometimes you'll have more esoteric parameters or fields that you need to specify that are maybe not so easy to find in the documentation. In that case, kubectl explain can come to the rescue. Okay, oftentimes it will be fairly straightforward to find it in the documentation though. Okay, so that's all that I want to say as kind of highlights for the challenge that we did today. As you get ready for the actual exam, feel free to try this challenge on your own, and again, highly recommended to try each of the practice exams as many times as you need to really feel comfortable and practice your speed. Because it is a time-constrained exam, you will want to make sure that you have your muscle memory working for you during the exam as you're entering all those kubectl commands. And you may want to get some practice in particular with VI. So a lot of the shortcuts in VI can save you quite a bit of time. It's definitely worth refreshing that. Cloud Academy has content related to VI as well. And I think if you do that, you should be in good shape for the actual exam. And with that, I will conclude the formal part of the session today and open it up to any questions that you may have. Okay. So one question that came in was, does the actual CKAD exam allow multiple terminal windows? So unfortunately, you are limited to just the one window. That's part of the embedded interface of the exam. So in that case, we do recommend that if you want to use multiple terminals, that you look into the use of TMUX, the terminal multiplexer, which will be pre-installed on any of the exam environments. Cloud Academy does have a lab specifically focused on using TMUX for the Kubernetes exams. So I highly recommend you take a look at that, because sometimes it is useful to have multiple shells where you're running kubectl commands on one side of your terminal and editing a file, a manifest file on the other side. Another thing worth noting, kind of relevant, is that the exam environment does have a notepad feature. So if you are, just want to take a few notes as you collect things, you can leverage that notepad feature that's embedded into the exam experience. Okay. Where can we get more practice? So the CKAD learning path is comprehensive and covers what you need for the exam. Definitely go through that as your first stop. We do have multiple practice exams covering the main domains of the exam. And again, those practice exams do include full solutions, not only explaining one perspective, but giving you different perspectives on how you can approach each task, and you can kind of see which way you prefer and which way you can execute most efficiently during an actual time-constrained exam. As well, we have had past webinars on CKAD, so definitely check out Cloud Academy's webinar archive, and you'll find some webinars that are covering at a higher level more general strategies for the exam and not specifically tied to a specific lab challenge. So that's what I would say. Check those out. If you complete those, I think you'll be in good shape for the actual exam. And that's all the questions that came through. So I'm going to hand it back to Tia. And thanks everybody for attending today.
Perfect. Thank you so much, Logan, for your time and your expertise. I'm sure there's people out there that found this super helpful as they were going along the lab with you. Just a few reminders before we all depart. One, thank you all again for attending today. I hope you found it informative. Additionally, as Logan said, you can check out some more on-the-demand webinars on cloudacademy.com/webinars. And at that point, that concludes today's webinar, and we hope that you have a wonderful day, and we hope to see you in the future at another webinar. Thank you all so much for your time. Bye-bye.